Hey everyone, welcome back to the Deep Dive. Today we're going to be looking at some research that could totally change how we think about animation.
Yeah, it's really cool stuff.
So imagine this. Okay, you have a 3D model of something like your favorite toy when you were a kid.
Hmm.
Or, I don't know, maybe a rare plant you saw at a botanical garden.
Oh, cool.
And you want to bring it to life.
Okay.
You want to make it move, but just by typing a few words.
Yeah, like a text prompt.
Exactly.
That's basically what this research paper is about, bringing objects to life.
Catchy title.
It is, and they figured out a way to take any 3D object and animate it just based on those text prompts.
But how's that different from what we can already do with like animation software and stuff?
Well, the problem is most of those tools that generate 4D content from text, they don't really give you much control over the final look.
Yeah, you end up with like these weird blobs, right?
Yeah, basically. And this method is different because it lets you animate a specific object that already exists.
So it keeps all the details of the original.
I like it. So how does this actually work? They mentioned this 3 to 4D thing in the paper.
Right, 3 to 4D, that's the name of their new method, and it's actually a two-step process.
Okay.
So first they create what they call a static 4D NeurF from the 3D object.
You're not familiar with NeurFs?
Yeah, basically, imagine building a super detailed 3D model,
Sure.
but it captures how light interacts with it from every angle, not just the shape.
Oh, so it's like a digital twin of the real object.
Exactly. And because it exists in this 4D space, it can move.
Okay, cool. So we've got the
Okay.
digital twin. What happens next?
Now comes the fun part. They use what's called an image-to-video diffusion model, which basically means it can turn still images into moving videos.
Got it.
And this is where your text prompt comes in. You tell it what you want the object to do,
Okay.
and the model figures out how to make that movement happen while keeping all those details.
So I could type in the plant blooms, and it would make the leaves open and the petals unfurl.
Exactly. And it'll look way more realistic because it's using that detailed 4D model.
This sounds super complicated. Were there any challenges they had to figure out?
Oh, for sure. Like just combining those technologies wasn't enough for smooth, realistic movement.
Yeah, I bet. It can't be that easy.
No, definitely not. One thing they came up with is called viewpoint sampling.
Viewpoint sampling.
Yeah. It's like if you were a filmmaker starting with a close-up shot and then slowly zooming out.
Ah, so by gradually expanding the view, you see how the whole object should be moving.
All right. It gives the AI a better understanding.
That's really clever. What else did they have to overcome?
Well, another big thing was making sure the animation stayed true to the original object's shape.
Right. We don't want it turning into a blob.
Exactly. So they developed this thing called attention masked SDS. It uses these attention maps to tell the model which parts of the image to focus on.
So it's like the AI is learning to pay attention to the right details.
Yeah, just like a human animator would.
This is fascinating. So how did they test all of this out? What kind of results did they get?
They used this huge data set called Google Scanned Objects. It has all these high-quality 3D scans.
Okay.
And to make the text prompts, they actually used ChatGPT.
Wow, they're using AI to control AI.
Pretty cool, right?
That is so meta.
And they found that 3 to 4D was way better at creating those dynamic animations while also keeping the original object's look.
So it's not just making your toy dance, it's making sure it still looks like your toy.
Exactly. It's
Yeah.
a big step forward. But it also raises some interesting questions.
Yeah, like what?
Like, what could this mean for other fields beyond animation?
Ooh, good point. Like education?
Yeah.
Maybe students could interact with 3D models of historical artifacts?
I like that. Or explore the human body in a totally new way.
That would be amazing. Instead of just reading about the solar system, they could create simulations of the planets.
Yeah, and it's not just education either. Think
Mhm.
about gaming or VR, creating entire virtual worlds that respond to you.
That would be incredible. But this research is still pretty new, right?
Yeah.
Are there limitations?
Oh yeah, definitely. The researcher said that the realism of the animations is still limited by the video generation technology we have now.
So if we want those really lifelike animations, we need better video tech first.
Exactly. Like building a house, you need a solid foundation.
Makes sense. What else needs to improve?
Well, right now the animations are all driven by text prompts. But imagine controlling the movements with gestures or even your voice.
Whoa, that would be so cool. It'd be like conducting an orchestra of animated objects.
And then there's collaborative creation.
Hmm.
Imagine multiple users working together to bring objects to life.
The possibilities are endless. So we've talked about the potential of 3 to 4D and the areas where it can still grow. What's one big takeaway, something that wasn't explicitly said in the research that you want our listener to remember?
You know what I think is really mind-blowing about this technology? It's not just about bringing static objects to life. It's about bringing ideas to life.
Oh, I like that. What do you mean?
Well, we're talking about taking an idea, a concept that's only in our heads,
Yep.
and making it into something you can see and interact with.
Like making the intangible tangible.
Exactly. Imagine taking something abstract like a scientific theory or a philosophical argument and turning it into a 4D animation.
That's deep. That could totally change how we communicate and learn.
Absolutely. It could unlock all these new forms of creativity and understanding that we haven't even thought of yet.
That's an amazing thought. I think our listeners are going to need a minute to process that one.
Yeah, it's a lot to take in.
It is. But that's what's so great about exploring these new ideas. So if anyone wants to dive deeper into the research themselves, where can they find it?
The paper's called Bringing Objects to Life, 4D Generation from 3D Objects. We'll put a link in the show notes.
Awesome. And if anyone out there has any thoughts or questions, we'd love to hear from you. Hit us up on social media with the hashtag #DeepDive4D.
Yeah, we're always happy to keep the conversation going.
All right, well, on that note, I think it's time to wrap up this part of our deep dive into the world of 4D generation. It's been incredible exploring this new technology with you today.
Me too. It feels like we've only just scratched the surface of what's possible with this.
I agree. I think we're going to be hearing a lot more about 3 to 4D in the years to come.
It's definitely one to watch.
But for now, I think it's time to take a little break.
Sounds good to me.
Before we sign off, though, I want to leave our listener with one final thought. We've talked about all the technical details and the potential applications, even the philosophy behind bringing these static objects to life.
Right.
But you know what really stood out to me? The sense of wonder and possibility that this technology brings.
It's like rediscovering the magic of animation.
Totally. That feeling of seeing something come to life out of nowhere, telling stories, expressing emotions. It just taps into something deep inside us, you know?
That childlike awe.
Yeah. And who knows what incredible new worlds and experiences we'll be able to create with this technology.
I can't wait to find out.
Me neither.
Yeah.
So to our listener out there, keep exploring, keep that sense of wonder alive, because who knows, maybe you'll be the one to unlock the next breakthrough in 4D generation.
Until next time.
This has been the Deep Dive. Thanks for joining us. Okay, so we've seen how this 3 to 4D thing works and what it can do, but I'm curious, like, what does all this mean for the average person? You know, beyond just cool animations.
Oh, that's a great question. And I think the impact goes way beyond just cool animations.
Yeah.
Like, think about education for a second.
Okay, yeah.
Imagine students being able to interact with 3D models of, like, historical artifacts or explore the human body in a whole new way. It would be amazing.
Yeah, instead of just reading about the solar system in a textbook,
Right.
they could use text prompts to control simulations of the planets moving around.
Exactly. And it's not just limited to education either. Think about the possibilities in gaming or VR.
Oh, yeah.
You could create these virtual worlds that respond to your actions, all based on simple text commands.
Wow, that would be mind-blowing. But you mentioned this research is still in its early stages. Does that mean there are limitations to what it can do right now?
Yeah. Yeah, there are definitely areas where the technology can still improve.
Yeah.
Like, for example, the researchers pointed out that the realism of the animations is still limited by how good our video generation models are.
So to get those really lifelike animations, we need to improve the video generation tech first.
Exactly. It's like you were saying before about the house.
The foundation.
Right? You need a strong foundation before you can add all the bells and whistles. Another area for improvement is user interaction. So right now the animations are all driven by those text prompts.
Right.
But imagine if you could use gestures or even your voice to control the movements in real time.
Whoa, that would be so cool. It'd be like conducting an orchestra, but with animated objects.
I love that analogy.
Yeah.
And then think about the possibilities for collaboration.
Like multiple users working together.
Yeah, each person contributing their own ideas and movements. The potential is huge.
So we've talked about all this amazing potential of 3 to 4D, but also those areas where it needs to grow. What's like one big takeaway, something that wasn't specifically mentioned in the paper, but something you really want our listeners to walk away with today?
You know what I think is truly mind-blowing about this whole thing?
Yeah.
It's not just about bringing static objects to life. It's about bringing ideas to life.
Oh, I like that. Expand on that. What do you mean?
Well, think about it. We're talking about taking an idea, a concept that only exists in our minds,
Okay.
and turning it into a visual experience, something you can interact with and explore.
So like making the intangible suddenly tangible.
Exactly.
Yeah.
Imagine taking something abstract like a scientific theory or a complex philosophical argument and turning it into a 4D animation.
Whoa, that's a powerful thought. It could totally change how we communicate, learn, and even think.
Absolutely. It could unlock entirely new forms of creativity and understanding that we can't even imagine yet.
That's heavy stuff. I think our listeners might need a moment to let that sink in.
Yeah, it's a lot to take in, but that's what's so exciting about exploring these new ideas.
Absolutely. So for those listening who want to dive deeper into this research themselves, where can they find it?
The paper's called Bringing Objects to Life, 4D Generation from 3D Objects. We'll be sure to include a link in the show notes.
Fantastic. And if any of our listeners have thoughts or questions, we'd love to hear from you. You can find us on social media using the hashtag DeepDive4D.
Yeah, we're always excited to keep the conversation going and see where these ideas might lead.
Okay, well, on that note, I think we're ready to move on to the final part of our deep dive into 4D generation. Okay, so we're back and ready to wrap up our deep dive into 4D generation. It's been really incredible exploring this new technology with you today.
I agree. It feels like we've only just scratched the surface of what's possible.
For sure. But for now, it's probably time to bring this deep dive to a close.
Yeah, sounds good.
But before we sign off, I want to leave our listeners with one last thought.
Yeah.
We've talked about all the technical details and the potential applications, even the philosophical implications of bringing static objects to life with this 3 to 4D thing.
Right.
But what really struck me throughout our conversation is that sense of wonder and possibility that this technology brings. You know what I mean?
It's like rediscovering the magic of animation all over again.
Exactly, that feeling of seeing something inanimate suddenly come to life, expressing emotions, telling stories. It just taps into something deep within us.
That childlike awe and curiosity.
Yeah. And who knows what incredible new worlds and experiences we'll be able to create and explore with this technology as it keeps developing.
I can't wait to find out.
Me neither.
Yeah.
So to our listener out there, keep exploring, keep questioning, and keep that sense of wonder alive. Because who knows, maybe you'll be the one to unlock the next breakthrough in the world of 4D generation.
It's a thought-provoking idea.
It is. And with that, this has been The Deep Dive. Thanks for listening, everyone.